Hello, good morning to all. Okay, so today we are going to discuss on the trigonometric identities, and this is the last subtopic of the introduction of trigonometry. So, to do the trigonometric identities, number one, what do you mean by identity? In lower classes, you learn about the identities, which means having an equation. So, exactly same here in trigonometric identities. The identity means an equation, but trigonometric identity means an equation involves trigonometric ratios, and we had already learned about the 6 trigonometric ratios, and we are going to use these ratios in an equation which we call as the trigonometric identities. Now, before we'll move to the examples to use the trigonometric identities, let us derive some of the important trigonometric identities. Okay, let's see. For every trigonometric ratios, we did discuss that the triangle should be a right angle triangle, and this is exactly the right angle triangle. So instead of writing A, B, C, P, Q, R, simply write that. Now, the most important thing is either of these two angles, we recognize one of the angle as the given angle. Suppose if you are going to choose this angle and the opposite side is this. So opposite side, or you say is the perpendicular. And if you are going to choose this angle and this is your P, perpendicular, isn't it? So any of these, but this angle is already 90. So suppose say we are taking this angle theta. If this is the angle theta, which means this is your P and hypotenuse, there's no doubt, isn't the opposite of the right angle, and this is your B. So remember this, and why this becomes a P? Opposite side of the given angle, and this is adjacent. Right? On the base of this, now we are going to derive the 3 major identities. Right? Now, suppose say, and in this right angle triangle, we are going to use the Pythagoras theorem. And so here the Pythagoras theorem, which says that h square, which is equal to p square plus p square. So this is the Pythagoras theorem, isn't it? So we write here, and this is the Pythagoras theorem, isn't it? Which means the hypotenuse square is equal to the square of the sum of the other two sides. Now, if suppose I'm going to divide one by one, first I'm going to divide by h of this equation, and then we take another. Let's see. For example, say first derivation is number 1. If we have this equation, say p square plus b square is equal to h square. If we divide by h, now let's see, h means here h square. If we divide by h square and by h square. Now square means we take as a p by h whole square, same thing, isn't it? And similarly here, plus b by h, again whole square, here cancelled and it becomes 1. Now in trigonometric ratios, that we have a ratio, so-called rho, isn't it? So what ratio gives the p by h ratio, isn't it? So-called rho, we write at the beginning, isn't so-called rho. So which trigonometric ratio gives p by h? That is sine, isn't it? Sine theta. Since angle is given here, the sine, isn't it? So sine theta, sine square of theta. And plus, and which gives here the b by h, cos, isn't it? Cos square of theta, which is equal to 1. Now what we get here is an equation involved trigonometric ratios, which we call as the first trigonometric identity. So this is our first trigonometric identity. Remember here, this is important here. Sine square theta plus cos square theta is always 1. When, now let's see, there is a one condition. So that condition is, now look at the theta. Look at this theta. In a table that we already discussed about the some of the values of trigonometric, the degree, which says that sine theta cos theta, and it says that the angles, I'll just show you the one again. So this is the trigonometric, the table is in, and says sine theta, that is sine of theta 0, angle 0, if angle is 0, value is 0. Here we have a specific angle is given. And then cos, you say, if it's a 0, then we have a 1. And also in the 90, we have a value. So which means that to satisfy this equation, there is one condition. What kind of the angle should be, the theta should be. The condition is this angle of theta should be in either a 0 or greater than 0 theta, but equal or less than 90. So this is the one condition. The theta value can be a 0 or more than a 0. But look at here, 90 again. Should be a 90 or less than 90. So in between, either including the 0 and 90. So this is the condition of the theta. What kind of the value of theta should be needed here? Either is a 0 or 90 or in between. So this is the one condition. So that sine square theta plus cos square theta equal to 1 is our first identity. Remember this? Condition. This is important. Remember here. Condition the because we already discussed about the degrees, isn't? And how many degrees that we have? The 5. 0, 30, 45, 60, 90. Dinga jiwa ngaki value natan ching paina. Ngaki value natan ching paina rwa. Di nano la sine dan cos na la either it can be a 0. 0 yung chugre, 90 yung chugre, or in between. Now the second condition here, if we are going to divide by the whole of this equation, equation Pythagoras theorem dela, yang want to divide down. For example, say big divide down chasha. In the first part we divide by h. Now divide by b. Say b square plus b square is equal to h square. It's the Pythagoras theorem. If we are going to divide by bh, so divide by bh, divide by bh, and divide by bh. Now convert these to the trigonometric ratios, and the trigonometric ratio will give p by b. P by b. Remember this, p by b. So that gives by tangent. Tangent square. Or either for us you write like this. P by b whole square, and here b and b we can cancel here, isn't it? B by b whole square, which is equal to h square, h by b square. Now this p by b is given by the tangent, isn't it? So I write in different color. Tangent square of a, tangent square of theta, and why I'm writing here theta is the given angle, and plus if we cancel this, it is a 1, which is equal to, now h by b, what gives the relation h by b? And h by b is the inverse of sum. Over here h by b gives by cos, h by gives by cos, isn't it? And if it is inverse, but h by b, the inverse of cos, we'll already learn about the reciprocals. The cos inverse is sec, isn't it? So that means sec square theta. So it's a sec square theta. And this is our second identity. So first identity, second identity. Now for this condition that we have again another condition. So that condition again will move to the trigonometric table here. So in this trigonometric table, what it says, what kind of the theta it should be. Now let's see here. Tangent and sec. Tangent and sec. This is the sec theta and tangent theta. Can be possible. The 0 is possible here. 0 in tangent. If it's a 0, can be possible. Tangent is 0. And sec is a 1. But look at the 90 value. Let's see here. Tangent and sec. The 90 value. Both of these are not defined. Which means we are not able to write the 90. But less than 90. So which says that the condition is that theta can be equal to 0 theta. But here the important thing over here is not equal to 90. So this is important. Not equal to 90 but less than 90, equal or greater than 0. So in between this, the condition is satisfied. So this is our the second identity. And then for the third identity is exactly the same actually, only that we are going to divide by p. So let's see here again, p by b is the identity. So p square plus b square is equal to h square. Pythagoras theorem, and divide by p to all these p square. So here p square and here p square and p square. So exactly same here, p by p whole square plus b by p whole square, which is equal to h by p whole square. And p cancels, it's a 1 plus. Now b by p means, now look at here, b by p. If p by p is tangent, the inverse of p by p is b by p, which is cot, isn't it? So cot square of theta, which is equal to, and what is the inverse of h by p, and what is the relation of the ratio p by b? P by b gives by this sign. The inverse sign is cosec, isn't it? So cosec square of theta. Is this clear? H by p and p by h is different. P by h is sine. Sine sine inverse cosec. So cosec p by h. H by p inverse here, sine inverse, and that is cosec. So this is the third trigonometric identities. And for here the condition is, these are the condition is exactly the same thing here. When we look at the cot and cosec, if it is a theta is 0, then having the problem. Let's see here. Cot and cosec. So last is cot here and cosec is here. So look at the value of the degree 0. Degree 0 in value not defined, not possible here. So that means 0 is not possible, the value of here. So which means 0, the greater than 0 of theta, and can be equal to 90. Say here degree. So degree 90 is possible, but it's not possible the 0 value. And if it is 0, the value is not defined. So these are the three, say the important identities of trigonometric ratios. Listen, in a trigonometric ratios, the most important identity is the trigonometric identities are the number 1 is 2 and 3. And there are some also important things which we call as the inverse or the reciprocals. So reciprocals are important for solving this kind of questions. And then there is another relation here. Quotient relation. So here we have another relation, quotient relation, which says if it is a tangent of theta, which we say sine theta divided by cos of theta, and then inverse of this is cot of theta, which is equal to cos theta divided by sine of theta. So now, in this can be also written as here, for example, say if you need the sine square theta, which means transfer this to the other side, it becomes sine square theta is equal to 1 minus cos square theta, and this can be also possible, isn't it? Exactly from here, if you want tangent square theta, say that means sec square theta minus 1. So converting here first, second, third, total that we have a 9, 3, 3 and 3. So now on the base of this, let us do one examples. Okay, now I'm going to take two examples how we are going to use these trigonometric identities to solve other trigonometric identities, right? We are going to use these identities, the first three identities and these questions and the inverse relations. So we are using those identities or inverse or quotient relations to prove this. Left hand side and right hand side should be equal, isn't it? Then let's see here. Taking and this is a first example. Say here the first example is sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. By solving this, what should be the result? Should be the tan of theta. Let's see here. Take. Since here the sine and sine are common, we'll take the sine as a common. So sine theta taking common, and what is left here? 1. And here 2 sine square theta is left. And divided by 2, here 2, okay, say taking again the cos and cos. Cos of theta, so 2 cos square theta minus 1. Isn't? Okay, now to get here the tangent theta, we already get here. Sine theta divided by cos theta is a tangent. Now what we are going to do is to change some from here and to remove all these things. And right now let's see here. And we know the identity, one identity, that is a sine square theta plus cos square theta equal to 1. That the identity of the proof so that the proof sine square theta is equal to 1 minus cos square theta. So convert the sine square theta. Sine square theta convert. Now this is a sine of theta 1, not a 3, negative, and okay 2, take common 2. And say here sine is equal to 1 minus cos. 1 minus cos square of theta. And divided by, write the same here, cos of theta 2 cos square theta minus 1. Now if you are going to open this bracket, see here, which is implied that sine theta, this is 1 minus, now multiply here, 2 into 2, negative 2, and negative into negative, it's a positive 2 cos square of theta. And say here cos of theta, and what is left? 2 cos square theta minus 1. And say subtract this, what we get here implied sine of theta, and subtract negative 1 and plus 2 cos square of theta divided by cos of theta. Now just arrange this, the same, either you can write this, isn't it? Plus 2 cos square of theta, exactly same these two, just cancel it. What is left here? Sine theta and cos theta. And what is the value of sine theta and cos theta? Sine theta by cos theta is a tangent, which is equal to tangent of theta. Prove that left hand side is equal to RHS. So same thing here, I'm going to take another example. Okay, the most of questions say that we are going to use these questions, the inverse relations, all these identities. Okay, take here another example here. The second example is sine A minus, the cos A minus sine A plus 1. And here cos A plus sine A minus 1. Now this equation while we are solving must be cosec A plus cot A. Now what kind of the identity we are going to use here? The first thing here, we are going to divide these one by one. For example, I'm saying that I'm going to divide whole of this by sine and here by sine. And why we are going to take sine dividing? Because look at here, if we are going to convert this, the reciprocal for cosec inverse is 1 by sine. Denominator is sine, isn't it? And here in a cot again, inverse of sine. That means cos by sine. Both of these having the denominator sine. And because of this, I'm dividing whole of this by sine theta. So divide sine theta to all. So this is important here. So sine theta. For example, see if I divide it here, cos of A divided by sine of A. Sine of A minus here sine of A divided by again sine of A plus 1 divided by again sine of A. I'm dividing nothing here. Only thing is I just divide 1 by 1 as a sine, sine, sine. Whole divided by exactly same here is a cos of A again sine of A plus sine of A divided by again sine of A minus 1 divided by sine of A. And why I'm dividing sine of A? As I explained earlier, because both of these having the denominator sine. So that's why I'm dividing here. Now let's hear. This is sine by, say here, cos by sine is a cot, isn't it? Cos by sine is a cot here. Cos by sine is cot theta, which means cot A. And cancel minus 1. And plus the inverse of sine, again inverse relation. Inverse of sine is cosec. Cosec of A whole divided by here cos by sine again is a cot, isn't it? Cos by sine, exactly the same here. Cot of A cancelled plus 1 and here inverse of sine again cosec of A. Alright, now what I'm going to do is here just rearrange the upper one, numerator, and then see what is happening here. See, cot of A plus cosec of A minus 1, and write the denominator same as here, cot of A minus cosec of A plus 1. Now another important identity that we have is, say, cot of A plus cosec A. There is again we have a relation cot and cosec. Say here cot and cosec, this relation is here, cot and cosec, which says that cosec squared theta minus cot squared theta is equal to 1. So 1 is already here. So instead of 1, we are going to put here cosec squared theta minus cot squared theta instead of 1. So we are going to put instead of this 1. Alright? 1 which is equal to cosec squared theta minus cot squared theta. So say here cot of A plus cosec of A minus Instead of 1, we are going to put here the cosec of A minus cot of A. Cosec square and cot square A. And divided by right are the same because we need cosec and cot. So write down here cot of A minus cosec A plus 1. Now look at here. Again we have another important identity, A plus B and A minus B, which is equal to A square minus B square. Exactly is here. A square minus B square. What is A? Cosec, B cot. So converting here, A plus B, A minus B. A square minus B square. A square minus B square equal to A plus B, A minus B. So write down here the cot. Is a cot. So cot of A plus cosec of A. I'm going to write this, okay? Okay, negative. Write down here, bracket. Cosec A plus cot of A and cosec of A minus cot of A, whole divided by cot of A minus cosec of A plus 1. Now from all of this, and here this is another part, taking here positive as a common, cot of A plus cosec of A, cosec of A. So take this as a common, this and this as a common. So cot of A plus cosec of A, take common, and what is left here? 1. 1 is left here, and from here is a negative. So what is left here? Just open the bracket, this becomes a negative and this becomes a positive. Here is a negative because of this negative. Here is a negative. Cosec A, negative and negative positive. Cot of A. And in the denominator, what is left? Cot of A minus cosec of A plus 1. So let's see here again. 1 plus, negative cosec, cot A, exactly same. So just cancel it. And what is left here? Cot A plus cosec A. Cot A plus cosec A. Cot A plus cosec A. Left hand side is equal to right hand side. So these are just taken in 2 examples, and there are so many questions in the textbook also. So try to do those questions. Textbook na yoyo chiwado transfer pa try chiruchi. Ngi de example iran ni shme steme kurang nangle chigeng chiwo ka shishti na tesho an tindu chiwado transfer pa try chiruchi ne. Okay, thank you.